Alright, so today we're looking at how we graph simple rational functions. And the parent function of simple rational functions is this function right here, y equals 1 over x. The most distinct thing about these rational functions is their asymptotes. Okay, and that's the places where they're not defined. They have a vertical asymptote right here at x equals 0. So they have a vertical asymptote at x equals 0. And what the vertical asymptote does is it interrupts our domain. So like from left to right, we just hit this wall and then we have to jump over it. So for the domain, we say it's all the real numbers except our vertical asymptote is 0. And if you're wondering why it's there, I mean, think about this. The vertical asymptote is at x equals 0. If I put a 0 in for x, I'd have 1 divided by 0, right, which is undefined. So that's why we have an asymptote there. Our next asymptote is the horizontal asymptote. Let's see here. Write that in black. The horizontal asymptote is at y equals 0. So on the graph, that's right here, this flat line. Okay? And the reason that that happens is because this is an inverse relationship, this y equals 1 over x. You could rewrite this as x equals 1 over y. So again, if you plugged 0 in for y, you'd have an undefined relationship. So we'll ignore that for right now. So this horizontal asymptote, it interrupts our range. Right? So we're on our way up and then boom, we hit a wall, have to jump over it. So we say that the range is all the real numbers except 0. So just remember that the domain is tied in with the vertical asymptotes and the range is tied in with the horizontal asymptotes. And this is called algebraic notation. Alright, we're going to look at 3 different forms of this today. Y equals a over x, which is very close to the parent function. The parent function would just be setting a equal to 1. Then we're going to look at if you have a over x minus h and then plus a number on the outside. And then finally, if you just have ax plus b over cx plus d. Alright, so the first form that we're going to look at is the y equals a over x. So here I have an example of y equals 6 over x. If it's of the form where you just have a number over x, you're going to draw the asymptotes at x equals 0 and y equals 0, just like the parent function. So I'm going to take my highlighter and highlight at x equals 0, which is a vertical asymptote, and y equals 0. I know that my function cannot cross through these asymptotes. My next step is to plot points to the left and right of the asymptotes. So all you really have to do for this is you just kind of come up with a table. Okay? We're going to do x and y table. Alright, so here we look at the vertical asymptote only. I need 2 points to the left of that vertical asymptote. And if you think about it, I'd like to choose 2 points that 6 is easily divisible by. Right? So I'm going to choose -3 and -2. 2 points to the right of the vertical asymptote would be like 2 and 3. So let's make a note that whenever it says plot 2 points to the left and right of the asymptotes, that you're really just looking at the vertical asymptote. Alright, so let's actually figure out what these points are. If x equals -3, what's 6 divided by -3? -2. What's 6 divided by -2? Okay, and then 6 divided by 2 is 3. 6 divided by 3 is 2. So now I'm going to plot all of those points on this graph. Alright, now we're going to draw the branches. Oh, I need a pen. Of the hyperbola. Okay, so that's just a little bit of vocab. This shape is hyperbola, and these are called branches. Branches, these graphs want to be near those asymptotes, but they can't touch them. So just get real close to the asymptote and draw through. And on the bottom. And these things are reflections of each other. Okay, last thing that we need to write down is the domain and range. What interrupts the domain? Which asymptote, the vertical or the horizontal? The vertical. So my vertical asymptote was at x equals 0. So the domain is all real numbers except 0. And the range is the same thing, all real numbers except 0. Okay, now we're going to do y equals a over x minus h plus k. So this is whenever you just have a number divided by x plus or minus some number. Okay, so a lot of times this one won't even be here. So if it's just a number, no x is on the top. No x is in the numerator. So here we have an h and a k. Well, the asymptotes will be at h and k. And if you think about the last example, right? Whenever you just have a number over x, h would have been 0. So the asymptote was at 0. And then the k, if there was no number being added or subtracted to the outside, the k was also 0. Okay? Now, the way I'd rather you memorize the vertical asymptote, because this is how it always works, the vertical asymptote, all you do is set the denominator equal to 0 and solve. So in this example, we have a denominator of x plus 2. So my vertical asymptote, x plus 2 equals 0, x equals negative 2. Okay, so I have a vertical asymptote at x equals negative 2. So I grab my highlighter, I go to x equals negative 2, and I draw a vertical line. Okay, and then the horizontal asymptote, if there's ever a number like out here on the outside of the fraction, that's going to be our vertical asymptote. So this minus 1, we have a horizontal asymptote at y equals negative 1. So go grab your highlighter, go to y equals negative 1. Okay, so now I just need some extra points. I need 2 points to the left and 2 points to the right. So what are the next two? Oh, that's way too large. What are the next 2 points to the left after negative 2? To the left of negative 2, we have negative 3 and negative 4. So I'm going to put negative 4, negative 3, and then 2 points to the right of negative 2. Negative 1 and 0. So plug these in for x and solve for y. Alright, now once we have this table filled out, these just came from plugging in for x, we plot those values, negative 4, 1, negative 3, 3, okay, negative 1, negative 5, 0, negative 3, and just like last time, we'll get close to our asymptotes and draw these branches. Okay, finally, what's the domain? It's all real numbers except what? Negative 2. And the range is all real numbers except negative 1. That came from the vertical asymptote and the horizontal asymptote. The last form is ax plus b over cx plus d. So in this form, this is the only one so far that we've had an x in the numerator and in the denominator. Right? So, the vertical asymptote, we just talked about that. How do you find the vertical asymptote? set the denominator equal to 0 and solve. So where's my vertical asymptote? At x equals 3. So I'll go ahead and draw that. Okay, now my horizontal asymptote, this time I don't have some number just hanging out to the side of it, right, to shift it up or down. So, but since I have an x on the numerator and in the denominator, the horizontal asymptote comes from y equals a over c. So those are just the coefficients of those x values. So in our example, what is the a value?
2.
2. And what's the c value? 1. So I have a horizontal asymptote at y equals 2. And you know what? Since we've done the vertical and horizontal asymptotes already, let's go ahead and list out the domain and range. What's the domain? All real numbers. Oh my gosh.
Except for
All real numbers except what?
2
That's right. Except 3.
and 3.
All real numbers except 3. And that comes from the vertical. So then the range is all real numbers except my horizontal asymptote of 2. Now the only thing I'm missing are some extra points, right? I need 2 points to the left and 2 points to the right of which asymptote? Vertical. So I'm going to make my table. Okay, I need 2 points to the left of 3. Let's use 1 and 2. And 2 points to the right of 3, so I'll use 4 and 5. A lot of times it's easy to use 0 as well, like if you didn't want to use 1 or 2. Alright, so plug these values in for x and solve for y. And it's okay to get decimals. Alright, so we filled out our table. Now it's time to plot all of these points. Okay, so we've got them plotted as, if you always just choose the next two to the left and the next two to the right, you're always going to have reflections of each other. And then we just draw our branches, approaching the asymptotes. Nope, missed it. I couldn't see, I was covering it up with my hand. Alright, and that's graphing our simple rational functions.